Greetings 6th grade students and parents. This topic on this video is going to be about putting fractions and decimals on the number line. Eventually we're going to talk about negative numbers on the fractions and decimals on the number line, but we're going to start with just the positives. So here's your number line, and the number line is divided mainly into tenths. If you look at the blue markings, each one of these little markings is a tenth. Okay? A tenth is the same as the fraction 1 over 10, or the decimal 0.1, 1/10. This is 0, so this is nothing, like having $0. And if we go by tenths, you can count all the way up to 1 by tenths, or in other words, dimes, if you're thinking of it in terms of money. 1/10 or 1 dime, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths. So if you have the number 0.1, or the fraction 1/10, you can put it right there. It's close to 0, but it's in between 0 and 1, but way closer to 0 than it is to 1. The reason is because you just got to split the number 0 and 1 up into 10 spaces. 0 to 0.1, to 0.2, to 0.3, to 0.4, and so on. Once you get to 1, it starts over, except for this time, there's a 1 as the whole number in front of the decimal. 1.1. That means 1 whole and 1/10. 1.2. 1 whole and 2/10. 1.3. All the way up to 1.9. 1 whole and 9/10. And then we get to 2. And guess what? It repeats again. 2.1. 2.2. 2 and 3/10. 2 and 4/10. 2 and 5/10. And so on all the way up to 3. And then it will go again. 3.1. 3 and 1/10. So if you're trying to put a fraction on the number line, you can do two things. Suppose we have the fraction 1/2. 1/2 is an easy fraction to put on the number line because you can simply divide the number in half and put the number 1/2 halfway in between the 0 and the 1. You can mentally divide it into perfect halves and put the label 1/2. Then if you wanted to put, let's say, 1 and 1/2, you'd have to go past the whole number of 1 because, well, that's what this 1 means. You have one whole number and then a half more. For instance, if you pass that and you want to go 2 1/2, you go to the 2, and halfway in between the 2 and the 3 comes the 2 and 1/2. 2 wholes, 1, 2, and then a half more. 2 1/2. But the other way you can put any fraction on the number line is by turning it into a decimal. So sometimes it's easier for a student to take a fraction, turn it into a decimal, and then put it on the number line. So if you just use our method of numerator divided by denominator, top divided by bottom, you'll realize that 1/2 is equal to the decimal 0.5. 5/10. Well, luckily for us, we have our number line divided into tenths already, or you can mentally divide it into tenths. Now 0.5 means 0 wholes, so we didn't get to this 1 yet. We're still in between 0 and 1. We have to count 5 of the tenths, the little pieces. 1, 2, 3, 4, 5. And if you'll notice, that happens to be halfway between 0 and 1. That's where we put 1/2. If we did 1 and 1/2 as a decimal, you can write it like this. 1 as your whole number in front of the decimal, and then do top divided by bottom to get that 0.5. This becomes 1.5. So, when we look at our number line, we can start at 0, we can go all the way to the 1, and then count 5/10 from there. 1.1, 1.2, 1.3, 1.4, 1.5. There it is. The quarters are a little more tricky, but not much. If you actually convert them to a decimal, it's not so bad. If you take, let's say, the fraction 1/4, do the numerator divided by the denominator, and turn it into a decimal form, you will get 0.25. What this means is 2/10 and then 5/100. So if you look at our number line, you start at 0 because there's no whole numbers. So we're at 0. Well, we're looking for 0 and 2/10, and then a little more than that 5/100. So here we have 0.1, 1/10, 0.2, 0 and 2/10. Now 0.3 would be a little too high. We're looking for 0.2 with 5/100. So 0.2 and 0.3, well, the 1/4 or 0.25 will fall right in between there. If you're doing 3/4, you can turn it into a decimal and get 0.75. That means 7/10 and a little more. So 0 wholes, count 7/10, 0.7, and put it right in between the 0.7 and the 0.8. You can do the same with 1 1/4. Turn it into a decimal, 1.25. 1 whole, so that means we have to go from 0 all the way to the 1 to get that 1 whole. But then we just have to count 2 more tenths, 1.1, 1.2. Now, not quite 1.3 yet. It's 1.25, so it's a little bit more than 1.2. And it happens to be halfway in between the 1.2 and 1.3. Okay, so that's some basics of turning fractions into decimals in order to put them on the number line. But if you're given fractions that are tenths, that's a little bit easier. 1/10, you know, is equal to 1/10 as a decimal, 0.1. And if we split this number line between the 0 and the 1 into tenths, 1/10 would go here. Now here is not 1/10, this is 1 and 1/10. Because we are past that number 1 now. So now we have 1 whole, and then we're counting the tenths. Okay, this is important to know. But for 6th grade, mostly the tenths and the benchmark fractions, such as fourths and halves, are going to be the most usable ones. Now, let's talk about putting them on the positive and negative number line. So here's a problem that comes from textbook page 53. And it gives you these 5 decimal numbers. 3.5, which a student may recognize as 3.5. 2.5, which a student might recognize as 2.5. Negative 0.5, we're going to focus on this a little bit. Negative 2.5, and then 0.5, which is the same as a half. Well, the actual question is to graph these on the number line. And the importance of graphing is that you can tell, of course, number one, you can tell which numbers are bigger or smaller than each other. The other importance to graphing these on the number line is that then you can tell what the opposites are, or what the absolute values are. Opposites and absolute values were all taught in the last unit of integers, so the concept remains the same, just for decimals. But for this video, we're just going to focus on putting them on the number line, and then looking at smallest or biggest. So let's first look at this number, 3.5. And what this represents in the problem, I didn't read the problem, but this represents the water level of a tidal basin over time. So the water level is positive 3.5. So we start at 0. We're going to the right because we're going in the positive direction. The whole number is a 3, so we must at least move to the 3. Then we got to move 5/10 more. So the student can either mentally think of the 10 little spaces in between, 3 and the 4, 3.1, 3.2, or they could recognize that 3.5 is the same as 3.5, and that decimal of 0.5 comes halfway in between the 3 and the 4. So right here will be positive 3.5. Okay. Next, 2.5. Same thing, except for we're not reaching the 3 yet. We're just going to the 1, then the 2, And halfway in between the 2 and the 3, you get 2.5, which is the same as 2.5. Now next is very important, is a negative decimal. This is the first time the students are placing a negative decimal or fraction on the number line. This decimal can also be written as the fraction -1/2. Okay? But for now, we're going to keep it as a decimal. And like I said, this is the first time students are placing this negative decimal on a number line. And a common misconception among students is that they're unsure of how to count because we're going backwards. So if we're looking at 0.5, negative 0.5 that is, you still have to understand that there is a 0 in the whole numbers place. There are no 1s. So that means we did not get to this -1 yet. We are still in the zeros. So negative 0.5 actually comes before this -1. -1/2. So negative 0.1, negative 0.2, negative 0.3, and negative 0.5 would fall halfway in between the 0 and the 1. It's not quite 1 yet. Otherwise, there would be a 1 instead of a 0 here in the 1's place. So we don't quite make it to this -1 yet. We're just at negative 0.5, -1/2, or -5/10. Let's look at this one, another tricky one. -2.5. Okay? All the students have to think about is that there's this 2 now here, this -2 in the 1's place. So we're looking at the number line, start at 0. Now we have to move past the 1 and past the 2. Because it's a -2 and then a little more than that, 2.5, which can also be written as -2.5. So we must count. Here's -1, here's -2. Now we must go 5/10 more, or 1/2. So in between the 2 and the -2 and the -3 is -2.5. Or -2.5. And of course 0.5 is a positive number, so that would go halfway in between the 0 and the 1. 0.5. So here we have positive 0.5 and negative 0.5 on opposite sides of the 0. This is on the positive side, positive 0.5, positive 5/10 or positive 1/2, and this is on the negative side, negative 0.5, negative 5/10, negative 1/2. If there's a whole number, we have to count to that whole number and then count the decimals. So 3.5 would be about here. 2.5 would be in between the 2 and the 3 because we didn't quite get to 3 yet, otherwise there would be a 3 here. And of course the same thing on the negative side. Positive 2.5 is a little bit past the positive 2, so negative 2.5 is going to be a little bit past the negative 2. In fact, halfway in between the -2 and -3. Now that we have all these numbers on the number line, we can see that this way, okay, to the left gets smaller, while going to the right, more positive, gets bigger. So negative 2.5 is our smallest number. This would be our smallest, or lowest number in terms of water level. Negative 0.5 would be the next smallest. Then positive 0.5 would be the next smallest. Then 2.5, and then 3.5 would be our largest valued number. Okay, again, if you have any questions on placing positive and negative decimals on the number line, please reach out to me. Thank you and have a great day.